It started with a clean roadmap, 6 months, 3 major releases, clear milestones. The whiteboard was full, dependencies were mapped, and risks were identified. At the end of planning, there was a quiet, satisfying moment where everything felt perfectly aligned. For the first month, progress looked steady. Tickets closed, demos passed, status updates were uniformly green. The team felt a genuine sense of accomplishment. Then small things shifted. A customer mentioned a new expectation. A competitor released an unexpected feature. An internal integration took a few days longer than planned. None of it felt dramatic at the time. But by month 3, the energy in the room changed. The demos felt tighter, less exploratory, and more defensive. In Slack, someone asked, "Are we sure users still want it this way?" The message was answered with a thumbs-up emoji and a firm reminder of the impending deadline. By month 5, changing direction felt too expensive. The design was locked in. The marketing copy was drafted. The team pushed through and shipped perfectly on time. The only problem was that the product no longer solved the market's actual problem. The plan had been executed flawlessly. It simply outlived the assumptions that made it true. This common scenario is rarely the result of bad planning or a lack of effort. It happens because of a hidden mathematical mismatch in how the project was designed. This chart shows assumption half-life. The curve drops sharply over time, representing the expiring lifespan of initial project assumptions. As realities change, ideas expire. Now look at the second line, feedback latency, the delay before learning an action's value. Notice the massive gap between them. When the rate at which assumptions expire exceeds the speed of feedback, project drift becomes inevitable. Structural failure occurs whenever feedback arrives slower than reality shifts. Traditional predictive planning relies on environmental stability. This approach is highly effective for physical construction, like building a steel bridge, where the environment is controlled, materials are predictable, and external changes are rare. But software and product development happen in fluid environments, where requirements evolve rapidly. In these contexts, an upfront plan often becomes a liability. Scrum functions as an architectural intervention designed to solve the feedback latency equation, shifting the focus from meeting schedules to the rate of learning. Think of sprint boundaries like the headlights on this car. You are driving in the dark, and the headlights only illuminate a short distance ahead. By deliberately limiting planning scope to a short cycle, teams navigate immediate challenges without exposing the entire project to massive risk. By imposing fixed time boxes and strict boundaries, Scrum intentionally trades long-term planning flexibility for immediate, rapid flexibility in learning. In traditional structures, a single project manager controls scope, schedule, and cost. While this feels organized, relying on a centralized authority to make every decision slows down learning and creates a bottleneck in complex environments. Scrum fractures this centralized control into specific structural stabilizers. The product owner protects the coherence of the value. The developers protect the integrity of the integrated system, and the Scrum Master protects the empirical discipline of the team. When responsibility isn't distributed and work processes remain hidden, technical complexities and misalignments compound silently. You only discover the integration issues months later, when fixing them is expensive. Specific artifacts, like the product backlog and the working increment, exist to force transparency. They pull hidden work into the light. Regular Scrum events serve as mandatory inspection points. They force the system to collide with reality, analyze data, and correct trajectory. By distributing authority and enforcing strict visibility, the system forces critical problems to surface while they are still small, contained, and cheap to fix. But there is a cost. Empiricism, the act of making decisions based on observed evidence, intentionally creates emotional friction within a team. When work becomes visible, delays can no longer hide. This transparency destroys plausible deniability, forcing teams to have uncomfortable, difficult conversations about underperformance much earlier in the timeline. To escape that discomfort, organizations often strip the framework of its intent, turning Scrum into a rigid reporting mechanism. They hold the meetings and collect the metrics, replacing genuine inquiry with superficial compliance. Maintaining the rituals without acting on feedback creates an illusion of progress. It looks like discipline, but it is actively masking a systemic decline. This is why Scrum is deliberately incomplete. It outlines constraints and feedback loops, but it refuses to prescribe exactly how a team should execute its daily tasks. Prescribing specific, rigid steps would weaken a team's adaptability, as static instructions cannot survive the unique, shifting contexts of a complex project. This structural minimalism acts as a deliberate constraint. The absence of strict instructions forces teams to develop their own practices and evolve them when operational pressure intensifies. Scrum operates as a deliberate architectural constraint, prioritizing the speed of learning over the speed of execution to catch failures before they become too expensive.